exponentials, exponential versus linear growth. As we begin to learn about a new kind of relationship, exponentials, it will be useful to compare the growth of this new form to the growth of linear relations. Remember that linear relationships have a constant additive growth. As the x value increases by a constant additive amount, the y value also increases by a constant additive amount. And we're going to be looking at example 1. This shouldn't say example 1 and 2 here, just example 1. And I'll fix that on yours. So let's look over here at example 1. In the equation, the constant additive amount is right here. This is the constant additive amount. Additive, meaning it's adding. And remember that since that is the slope, we can see the two parts in our table. Remember that slope is delta y over delta x. So our delta y is plus 2. So we're growing by 2 each time in our y values. And our delta x, the 3, we can see here that we're growing by 3 in our x values. So each time that the x value increases by 3, the y value is increasing by 2. And that is constant additive growth. So that's linear growth. And in our table, or in our graph, we can see that when we go from this point to this point, we go to the right 3 units, so our delta x is 3, and we go up 2 units, so our delta y is 2. And so that matches up with what we see in our table and our graph. So that's linear growth. Okay? Exponential growth is different. It's different than linear growth in each of the 3 representations. The 3 representations there are the equation, the table, and the graph. The growth is also constant in exponentials, but it is constant multiplicative growth. That means that it's constantly multiplying by the same amount. This means that as the x values increase by a constant additive amount, the y values increase by a constant multiplicative amount. For example 2, we're going to look at the most basic exponential equation. And so let's do that now. So in the equation, 2 is the constant multiplicative. I'm not sure if I'm spelling that right. Constant multiplicative amount. You can correct me if you want to if I am incorrect. So what we see is that as our x values increase by 1, our y values are being multiplied by 2. And so you can see that's why it's a multiplier of 2. And in the graph, when we go, so what we're looking at is the distance from the x-axis to points on the graph, that distance. So here, from this point to that point right there, we go to the right 1 unit, and This distance is 1, and this distance is 2. Then we go to the right 1 unit, and this distance is 4. And then we go to the right 1 unit, and this distance is 8. Then we go to the right 1 more unit, and this distance is 16. So you can see right here that we are multiplying by 2 each time. And that is exponential growth. Notice that in the equation, the variable x is in the exponent of the number 2. So in the equation here, the variable, I'm going to zoom in again, x is in the exponent. And that is a key feature of exponential equations. So this is exponential versus linear growth.